So in a field that is like, I would say, oversaturated like data science right now. When I say oversaturated, not in terms of talent, in terms of influx of people, in terms of the noise in the industry. Everybody today wants to be a data scientist. Nobody even understands what is a data scientist. The parents don't know anything about data science. Data science gives good money, so you become a data scientist. This is the rationale. So in a space like this, where I would not say overcrowded talent, talent is still a big issue, but the influx of people is huge. Unskilled people is huge. How do you differentiate yourself, or in building your personal brand and say, this is what I am known for?
So you're saying supply is very, very high and not the right kind of supply, which I would agree. The talent density is still short in the field, and I will tell you where the talent density, the pockets in which the talent density is of shortage. Certainly at leadership levels, there is a wanting of good talent out there. When I mean that, we want at leadership levels, we want people who know deep technical expertise, but also have the nuances of solving a practical problem, and the executive presence, and how do you communicate your vision, and how it should be vision led, etc. So there is a lack of talent density at the leadership level itself, and that kind of percolates through the system. So at mid management, there are talent density issues, and at freshers also there are talent density issues. Now coming to freshers, on where the talent density is, it's very similar to what I talked even about leadership, right? What is plethora available? Plethora available is a lot of articles, a lot of code bases out there that you can quickly pull in and then build your own things on top of it. There are a lot of videos, there are a lot of ways in which you can learn the sciences, learn the codes, right? And hence the gaps start showing up because there is no appreciation of the problem at all before somebody moves to a solution. So people get trained heavily on the solution space. You have no connection to what the problems are, right? So that's where the gaps, and rightfully so. There's only so much academia can do towards it, in terms of making people appreciate the problems. Even if you get industry people to come and do regular lectures, this gap will be there, because appreciating and having an empathy, I want to use the word very deliberately, having an empathy to a business problem is very, very important. And that's a soft skill that would really differentiate a fresher from a person who kind of knows everything to know how to solve a problem. Problem solving becomes a very, very important aspect, and that is not a very trainable thing, right? There has to be also something inherently in you to draw you towards that problem, one, and also the ability to solve the problem given all the knowledge that you have. So the knowledge, there's a difference between knowledge and wisdom, right? So this is knowledge. You have plenty of knowledge out there. You can query chat gpt and get a code. You can work with copilot, all of that is there. But how do you convert the knowledge to wisdom, and how do you start solving actual problems, is where the gap is, right? And now if you think about your question on how do you differentiate here, therein lies how does someone seek opportunities to solve a real world problem, right? Which you talked about hackathons, and that's a great way to start it, because there somebody is presenting a real problem, then you are solving with that. There are industry conferences which students can attend, where people are talking about genuinely what those problems are, right? When they even if people are talking about core technologies, be it language models or anything, they do say the nuances of what kind of problems these are trying to solve, and that's another way to start understanding what problems are out there. I would say a student should spend 70 to 80% of your learning time in understanding what problems your area will help you solve. Then you figure out how to solve it, right? One of the this kind of many founders say this, right? For finding the problem is the biggest problem. Once you find the problem, then you can solve it. And it is the same thing while you are even coming to the industry. Figure out what are the problems these solutions are solving, right? If it is LLMs, or if it's your forecasting models, if it's your classic classifiers, if it is about building a dashboard, if it is about building a data engineering pipeline, the appreciation of what is it that you are solving is very, very important. And once you figure that out, and that's a seeking process, right? That's not going to show up to you. It's not a Google search where you say, hey, what are the top 10 problems that LLMs are solving today, right? It is not that simple, because then you get very textbookish answers. But you seek the problem, you understand where the differences are, you understand when you build a solution, it may look like it's good, right? But when you actually build it for an enterprise at an enterprise scale, then you know the nuances of, okay, this area it is not working correctly. These are the nuances. If you don't solve those nuances, then entire solution becomes useless, right? Sometimes you require accuracies or relevance greater than 95%, right? Which means a 90% solution is not 90% better. 90% solution, if 95% is the benchmark, is useless, right? So we need to understand those nuances of where are the gaps, and then you start working towards the gaps. As you work towards the gaps, then you actually build projects which are out there, which have solved something very differently than what others have solved, because of which a lot of people, I started out by saying, for me learning is by doing. And for those people in my bracket of learning by doing and not by learning by research papers or blog articles, you will start appreciating the fundamentals even more better. You will, for example, you will understand what is the stochasticity in a stochastic gradient model. Why does your weights have to be incremental? How do you kind of adjust for leakage of variables, etc.? As you solve these big problems, then your fundamentals get also very, very stronger. So my first thing, and I'm saying this, spend bulk of your time seeking the problem. Once you get hold of the problem, spend the remaining of the time solving it. In this method, you will kind of have a portfolio of things that people are impressed with. These are things that will also help you self reflect on where you are, and also help you go deeper in the subject that you are doing. That would be my stance on it.
So, kind of, distilling what you've said, is that there is a noise of around a lot of skills and tools that people know, that is all cluttered over the resume and their, personal profiles. But rather, I would appreciate if somebody has solved a specific lending problem for a. So, talking about the problems in the industries and the business impact that they've created would probably differentiate their profiles much better in data science than telling that I know Power BI, Tableau, ClickView, or I know Python, I know this NLP, I know CV, I know all these different models within NLP and CV. That would not make much of a difference, but much rather, if somebody says I've solved this problem, it is, reverse engineering, and I understand that he must have used all these things. So
Correct.
that is a way you would probably look at a person differently in terms of the personal brand that they're
Correct.
building.